Hi, today we're going to talk about the periodic table, which was first organized by, was the first organization of the elements by Dmitry Mendeleev, who was a scientist many years ago, and his original version looks a little bit different than ours, but it still has a lot of the same principles. So the basis of our periodic table is that there are rows, which we call periods, and columns, which we call groups or sometimes families. I'll usually refer to them as groups. And each row is organized by atomic number. Now, Mendeleev originally organized them by atomic mass because they didn't know the number of protons for each element. And that's a pretty, the trend holds pretty well for atomic mass, but there's a couple exceptions, but we organize it by atomic number. And then each group or family has similar properties. Okay, so the different ones that we are going to focus on, they're all labeled here, and they're labeled on the periodic tables that you have in class to access. But the ones I'm going to focus on are the alkali metals, which is group 1, or sometimes called 1A. The alkaline earth metals, which are group 2 or 2A, all right? The transition metals are this chunk here in the middle, and they're notable mostly because we often ignore them in a lot of the things that we do. They behave a little bit differently than the main group elements, which are all the other ones. But, you know, I will refer to them, so you should know that those ones there in the middle are the transition metals. They're in yellow in this picture. All right, and then the halogens are group 17 here, or group 7A on your periodic table. Both numbers are fine. And then the noble gases, which is the last column here, shown in purple. Okay, so those are the 5 groups that I kind of expect you to know and be able to identify. And the reason is that they have the same properties. So all of the noble gases, for example, don't really react very much with anything, and we'll talk a little bit later in the unit about why that is. Whereas all of the alkali metals are really reactive. And that reactivity changes as you go down a group for both, or for all of these groups. They have a trend. All right. The other thing that we're going to look at with the periodic table is 3 larger groups. So most of the periodic table is metals. All the stuff that's shown here in pink is a metal. All right. So some of them you're probably familiar with as metals. So like iron, which is Fe, or copper, which is Cu, zinc. Those are all things that you would recognize as metals. All right. The metals over here on the left, the alkali and the alkaline earth metals, are very reactive. So you rarely will find those as metals in nature. They're usually present having reacted with a nonmetal to form a salt. So for example, sodium is a metal, but the sodium that you put in your food has already reacted, and so it's in a different form. It's still a metal, but it's not the pure elemental metal. All right, and then the blue are all the nonmetals. Most of them are over here in the upper right corner of the periodic table, but then hydrogen is that one that's always behaves a little bit differently than the rest, is over here, but it is also a nonmetal. And then these yellow ones here that kind of hug the stair-step line, those are metalloids. So sometimes they have, they behave more like metals and sometimes more like nonmetals, all right? We don't actually do a whole lot with the metalloids in this class, but it will be important that you can identify which ones are nonmetals and which ones are metals. So go ahead and label your periodic table in your notes so that you have that as a resource to go back to.